Hello everyone, welcome back. Today I'll be covering articular cartilage, a part 1 video. Started off with what is articular cartilage, cartilage growth, various zones of adult articular cartilage, include superficial zone, middle or transitional zone, deep zone, Tidemark and calcified zone. Now let's get started. What is articular cartilage? Articular cartilage is a highly organized avascular tissue composed of chondrocytes embedded within an extracellular matrix of collagens, proteoglycans, and non-collagenous proteins. Its primary function is to enable the smooth articulation of joint surfaces and to cushion compressive, tensile, and shearing forces. Hyaline cartilage has one of the lowest coefficient of friction known for any surface-to-surface contact. Cartilage is avascular, aneural, and alymphatic. Hyaline cartilage is the most common and found in 1. Bone apophysis, 2. Synovial joints, as is articular cartilage, 3. Epiphyseal plates, 4. Costal cartilage, 5. Majority of the fetal skeleton. Cartilage growth by A. Appositional growth. New cartilage is formed at cartilage surface by cells derived from chondroblasts of perichondrium, the first surface of hyaline cartilage. With maturation, majority of cartilage growth is primary appositional. B. Interstitial growth. Increase in the internal mass of cartilage by activity of chondrocytes that multiply within their lacuna. In mature cartilage, cellular turnover rate is exceedingly low. Structure. Inspection of the articular cartilage from joints. It shows the surface to be smooth, shiny, and dense white. On palpation, the tissue is semi-solid and elastic in the sense that it indents with pressure and is restored to its original contour upon release. The color of immature articular cartilage is somewhat bluish, while in mature it is yellow. The thickness of human ranges from 0.5 mm to 5 mm on the patella. Cartilage are firmly fixed to the underlying subchondral bone and are very resistant to shearing stress. This picture shows an adult articular cartilage grossly. Histology of adult articular cartilage. Articular cartilage can be divided into 4 zones: superficial zone, transitional or middle zone, deep zone, and the calcified cartilage layer. Because the individual cartilage zone responds differently to mechanical loading, it is clear that the zonal arrangement of cartilage component is also important for the function of the cartilage. The superficial zone, around 10 to 20% of the total thickness, shows a tangential arrangement in densely packed collagen type 2 and 4 fibers, providing tensile strength and giving resistance to shear force that occur during joint motion. The surface layer is of great importance to nutrition as well as for the wear and lubrication potential of the articular cartilage. This Figure shows the schematic cross-sectional diagram of a healthy articular cartilage. The cellular organization in the zone of articular cartilage, you will see a lot of variation of this picture. There's 4 zones of articular cartilage: superficial zone, middle zone, deep zone, and calcified zone. Histology of articular cartilage. The cell density at the superficial zone is higher, while the matrix content is relatively low, with high collagen and low proteoglycan concentration. The content of fibronectin and water is highest in the superficial zone. Removal of this zone increases the permeability of the tissue and the stress on the macromolecular scaffold during compression, thereby altering the mechanical behavior of articular cartilage. This figure shows the zone in articular cartilage. Superficial zone, the chondrocytes is the most superficial, or tangential zone are small, immature and flattened, and the collagen type 2 fibrils are arranged in tangentially to the surface. For zone 2, transitional zone, it consists of proliferating spherical chondrocytes with collagen fibers oriented slightly perpendicular to the surface. Regarding transitional zone of articular cartilage, the transitional or middle zone is a transition area from the superficial to the deep zone in terms of its morphology and matrix composition. Its volume is as many times that of the superficial zone. Because of the matrix content, including the proteoglycan content, is higher than the superficial zone, the collagen fibers, which become thicker with increasing cartilage depth, are more widely spaced. The fiber arrangement are randomly orientated without a preferred direction. The water content in this zone is lower than in the superficial zone. This figure shows the 4 zones again: the superficial tangential zone, the middle zone, and the deep zone with calcified cartilage present. Both cell size and cell concentration are higher in the transitional zone than in the deep cartilage zone. The oval and hemispherical chondrocytes, respectively, are arranged in pairs or groups with no definite orientation. The thickest collagen fibers, the highest concentration of proteoglycans, and the lowest content of water are found in the deep transitional zone. Like the chondrocyte columns, the collagen fibers are perpendicular to and parallel to the articular surface. Again, this picture shows the arrangement of the cells in the superficial, transitional, deep, and calcified cartilage zone. For transitional zone and deep zone of articular cartilage, the cells of the transitional zone are the largest, round to spheroidal, and normally arrange themselves in groups of 6 to 9 cells in a columnar fashion perpendicular to the articular surface at low volume density. The main function of deep zone is to anchor the non-calcified in the calcified cartilage. However, this zone also contributes to the tension of the collagen fiber network due to its high proteoglycan content and the resulting swelling pressure. The transition zone is the first to withstand compressive forces, while the deep zone is more important for the resistance to compressive forces due to the orthogonal alignment of the collagen fibers in the deep zone. This is the most important figure of all the other pictures. This shows the zonal characteristic found in the articular cartilage. For superficial zone A has a horizontal that's mean parallel to the articular surface, the collagen orientation with low proteoglycan content. Chondrocyte is flat and higher cell density compared to the other region. For middle zone cartilage has a random collagen orientation, high proteoglycan content, and round chondrocyte. For deep zone cartilage, it has a vertical collagen orientation, perpendicular to the articular surface, and high proteoglycan content. The deep zone chondrocyte show columnar arrangement. The Tidemark and calcified cartilage of the articular cartilage. Tidemark is a boundary between the calcified and non-calcified cartilage. Histologically, it is a distinct line. The articular cartilage is interlocked with the rough surface of the underlying subchondral bone by a thin layer of calcified cartilage. Nevertheless, cartilage and bone remain separated. The calcified cartilage zone represents the transition between cartilage and bone. The amount of calcified cartilage is seen as a parameter for its adaptation to long-term stress. The chondrocytes of the calcified cartilage zone are relatively small and embedded in the surface of the calcification front, and each cell is surrounded by some calcified tissue. The calcification of articular cartilage and subsequent endochondral ossification is important in determining the shape of the joint and thus the load distribution. The feedback mechanism controlling the formation and progression of the calcification front seems to be related to the load on the articular surface. Again, this figure shows the zone in the articular cartilage. Superficial zone, whereby the fibers parallel to the surface. Transitional zone, random fibers. Deep zone, fibers perpendicular to the surface. The Tidemark. Then subchondral bone with cancellous bone. Yay, we have finished this video. See you in the next part 2 video. We started off with nutrition of the articular cartilage. Bye bye and take care.